This video is part of the lecture for multivariable calculus, and I'm going to talk about differentiation and integration rules for vector functions. So let me start. Differentiation, we said that in the last video we said that if we have a vector function r of t with the components a function of t, the y of t, and then z of t, the third component, then derivative would be derivative of each of the components, y prime t and then z prime of t. A vector function with parameter t is just has just one parameter. That's why we can use the prime for that. And we said that the derivative is actually a vector, as you see, and this vector is tangent to the curve of this vector function. And let me give you a note as well. We can define a vector t as derivative over the length of the derivative. The length is a number that is positive, and this vector in here is perpendicular to the function. So if we have this vector rt, then derivative would be tangent to the curve, and I multiply it by a scalar that is positive, so that's why this vector in here would be tangent vector, and it's also unit. We call it unit tangent vector because the length of it is just one unit tangent vector. And we use this a lot for solving questions. Now let's talk about differentiation rules. Differentiation rules. I'm gonna use just the function of a vector u to say a function of t, like that in my notation. Then I'm gonna say that derivative with respect to t of two vector functions u and v, it would be derivative of the first one plus derivative of the second one. Then if I have the dot product of two vector functions u and v, then it is like the product rule. And I'm gonna say that it would be derivative of the first one times the second one plus derivative of the second one times the first one. And as you see, this is a vector times another vector, and I get a dot product in here, which would be the answer would be just a number, and then in that case I also have the number. But if I have the cross product of two vector functions, then derivative of these two would be, again, draw product rule, derivative of the first one, cross product with the second one, plus the first one cross product with derivative of the second one. You see, and here when I have the dot product, I could change the order, because in the dot product I can change the order, but in the cross product I cannot change the order. It's just because in the dot product I have a number, but in the cross product I have a vector. So if I change, for example, if I write in here dv dt cross product with u, in that case I get in opposite direction of the vector that I'm actually looking for. So pay attention to that as well. Then another rule is that if I just have a number scalar times the vector function, derivative of that would be the number derivative of the vector function. If I have a function times the vector function, then derivative would be again product rule. Product rule. That one also was product rule. And I get derivative of f, let me call it f prime of t times u, the vector u, and then the function f of t times du dt. Okay, and the last one would be the chain rule, and I'm gonna write, if I have a vector function at f of t, then derivative of that would be derivative of the function that is inside times derivative of the vector function at f of t. This is chain rule. This is chain rule. So as you see, these rules are very much similar to where we have a function, except the dot product and cross product. In the cross product, we have the product rule, but I cannot change the order. Okay, let me give you just one quick example. And the example is this. The function r of t is e to the t squared I minus j plus ln of 1 plus 4t times k. Okay, now I want to find derivative of that. So derivative would be derivative of the first one, which is using chain rule. It would be 2t squared e to the t squared. Derivative of the second component is -1, so derivative of that would be 0. And the third component is natural log, and derivative of that would be 4 over 1 plus 4t. That's how we use derivatives and derivative rules. Okay, let's talk about integration. Integration. If I have a function that is vector function with three components, t and zt, then derivative of the vector function, you can guess, right? From a to b would be derivative of each of the components. It would be derivative of xt dt, derivative of the second component, and then derivative of the third component. Okay, let me give you a note. And the note is that, as you see, the integral here is actually a vector. So it is not the usual area under the curve. It's actually a vector. It is a vector. It's not even a scalar. It's not even a number. But what is that? I can just give you one idea. If you have x-axis, y-axis, and then z-axis, and then if we just have the curve of RT, and then I can start writing at every point I can make a vector. And then, for example, at this point I have this vector, at this point I have this vector, and I get a ribbon, as you see. And I can say that the area of this ribbon is actually 1/2 to be the magnitude of r of t cross product with r prime of t dt. But we are not going to work with that a lot in the course. Something else that is very important and we're gonna use, it would be the fundamental theorem of calculus. If you remember fundamental theorem of calculus, we said that for a function, we said that the integral of f prime of t dt from a to b, it would be the function at b minus the function at a. Remember that? So we have the similar situation for the vector function, and I'm gonna say that the integral from a to b of r prime of t dt, it would be r of b minus r of a. And the application of this would be application of the fundamental theorem that we are going to use is that we can use this integration to get the position vector from the velocity. Let me write this. We can integrate velocity to obtain change in position, and we can integrate acceleration to obtain change in velocity. Okay, so these are everything that we just need to know about the integration and also differentiation of the vector functions. On the next video, we're going to solve some examples working with integration rules and differentiation rules.